Welcome to The Mystery of Africa's Extinct Bears. Africa, renowned for its diverse wildlife, once hosted formidable bear species, including the giant Agriotherium africanum and the unique Atlas bear. These majestic creatures roamed the continent millions of years ago, shaping ecosystems alongside early hominins and megafauna. Yet today, Africa's bearless landscape begs the question: why did these apex predators disappear? Join us as we delve into their ancient history, ecological roles, and the factors that led to their extinction, unraveling the enigmatic story of Africa's lost bears. Bears, members of the Ursidae family, are some of the most iconic and adaptable carnivores on Earth. There are currently 8 species of bears that inhabit a variety of ecosystems, from the Arctic ice of the polar bear to the dense forests of the brown bear. Despite their adaptability and widespread presence, bears are conspicuously absent from Africa, a continent renowned for its diverse and abundant wildlife. The absence of bears in Africa is perplexing, particularly when considering the historical presence of these formidable creatures on the continent. Africa's current predator hierarchy includes lions, leopards, hyenas, and cheetahs. But there was a time when the continent also hosted one of the largest and most powerful bear species ever known, Agriotherium. This genus of bears, which included several species, once roamed various parts of the world, including North America, Europe, and Asia, as well as Africa. Agriotherium africanum, in particular, was a giant among bears, standing out not only for its size, but also for its unique characteristics and ecological role. Understanding the history and extinction of Africa's bears involves exploring the climatic and environmental changes that occurred on the continent over millions of years. These changes profoundly impacted the flora and fauna, leading to the rise and fall of various species, including the mighty Agriotherium. Moreover, the eventual arrival of the Atlas bear, a subspecies of the brown bear, in North Africa adds another layer to this complex story. The story of Africa's extinct bears is not just a tale of past biodiversity, but also a reminder of the fragile balance within ecosystems and the impact of climatic shifts and human activities on species survival. By delving into the history of bears in Africa, we can gain valuable insights into the dynamics of extinction and survival, which are crucial for modern conservation efforts. Chapter 1: Historical Presence of Bears in Africa. To unravel the mystery of why bears are no longer found in Africa, we must first examine the time when they did inhabit the continent. The most prominent bear that once roamed Africa was Agriotherium, a genus that included several large and powerful species. Among these, Agriotherium africanum was particularly notable due to its immense size and strength. This species, which lived during the Miocene and Pliocene epochs, was among the largest bears ever to exist, rivaling even the largest modern polar bears. It was a true giant, with adults reaching lengths of up to 2 meters, 7 feet, and weights of approximately 750 kilograms, 1,650 pounds. Such size would have made it a dominant predator and scavenger in its ecosystem, capable of challenging other large carnivores for food and territory. The physical characteristics of it, including its powerful bite and robust build, further underscored its position at the top of the food chain. The fossil record indicates that Agriotherium had a broad geographical distribution, with remains found not only in Africa, but also in North America, Europe, and Asia. This wide distribution suggests that it was highly adaptable, capable of thriving in various environments. In Africa, it would have coexisted with a range of megafauna, including early hominins, large herbivores like elephants and rhinos, and other predators such as saber-toothed cats and large hyenas. One of the most distinctive features of Agriotherium africanum was its bite force, which was the strongest of any known bear, living or extinct. This formidable bite allowed it to crush bones and access the nutritious marrow inside, a valuable adaptation for both scavenging and predation. The bear's skull was wide and short, concentrating immense pressure on a small area, further enhancing its ability to process tough and fibrous food sources. Despite its formidable attributes, the exact ecological role of Agriotherium africanum has been a topic of debate among paleontologists. Some researchers suggest that it was primarily a scavenger, using its size and strength to intimidate other predators and take over their kills. Others argue that it was an active predator, capable of hunting and killing large prey. Isotopic analyses of its teeth suggest an omnivorous diet, indicating that it consumed a mix of plant and animal matter. The presence of Agriotherium africanum in Africa for millions of years highlights the dynamic and ever-changing nature of the continent's ecosystems. Its eventual extinction, however, marks a significant shift in Africa's predator landscape, paving the way for the rise of other large carnivores and reshaping the ecological balance. Understanding the factors that led to the extinction of it is crucial for comprehending the broader patterns of survival and extinction in Africa's rich and diverse natural history. Chapter 2. Africa's Giant Bear. It was a colossal bear that roamed Africa millions of years ago. It was one of the largest members of the IT genus, a group known for their impressive size and strength. With adults measuring up to 2 meters, 7 feet in length and weighing around 750 kilograms, 1,650 pounds. It was comparable in size to the largest male polar bears. This immense size gave it significant advantages in its environment, making it a dominant force in its ecosystem. One of the most remarkable features of Agriotherium was its powerful bite. This bear had the strongest bite force of any known bear, living or extinct. Its skull was wide and short, designed to concentrate immense pressure on a small part of its back teeth. Each bite could generate over 4,500 newtons of force, nearly twice that of modern polar bears and grizzly bears. This incredible bite strength allowed it to crush bones with ease, enabling it to access the nutritious marrow within. Initially, some paleontologists speculated that it might have been more herbivorous than carnivorous. This hypothesis was based on comparisons with modern bears, where species with weaker bite forces relative to their size tend to be more carnivorous, while those with stronger bite forces are often more herbivorous. For example, the giant panda uses its powerful bite to crush bamboo shoots. Additionally, the overall skull shape of Agriotherium, which resembled that of a gelada baboon, a vegetarian primate, further fueled this speculation. However, the discovery of its teeth and subsequent isotopic analysis provided a clearer picture of its diet. These studies revealed that it was omnivorous, consuming large amounts of both plant matter and meat. The shape and size of its canines indicated a diet that included a significant amount of protein, as these teeth were well suited for piercing and tearing flesh. Despite this evidence, some researchers were reluctant to classify Agriotherium as a true predator. They proposed that it was a specialized scavenger, relying on its immense size to intimidate other predators and take over their kills. The debate over whether it was primarily a scavenger or an active predator continues to intrigue paleontologists. Those who view it as a scavenger argue that its limbs were not built for speed, suggesting it was too slow to catch prey. Instead, they believe it used its size to intimidate other predators, such as amphibianids, Homotherium, and Dinophilis from their kills. This strategy of kleptoparasitism, where an animal steals food from others, would have allowed Agriotherium to feed on the remains of prey caught by faster, more agile hunters. Once it had secured a carcass, it could use its powerful bite to break bones and access the nutritious marrow within. However, this scavenger hypothesis is not universally accepted. Many paleontologists believe that it was both a scavenger and a predator. Its large size and powerful bite would have made it a formidable hunter, capable of taking down a variety of prey. Moreover, the environment of Africa during its time was home to numerous megafauna, many of which were slow-moving. This abundance of slow prey could have provided ample hunting opportunities for Agriotherium, making ambush tactics less critical. The omnivorous diet of Agriotherium, supported by isotopic analysis, indicates that it had a flexible feeding strategy. This flexibility would have been advantageous in the diverse African ecosystems, allowing it to exploit a wide range of food sources. It likely hunted large game such as juvenile elephants, stegodon, hippos, rhinos, and chalicotheres. smaller prey would not have been exempt from its powerful jaws, as evidenced by the behaviour of modern bears like the sloth bear, which, despite being relatively slow and often scavenging, still hunts smaller animals. The possibility that it might have preyed on early human ancestors adds another layer of intrigue. Australopithecus, an early hominin that lived in the same regions and time period as it, may have encountered this formidable predator. Other primates, such as Theropithecus and Turcopithecoidea, might have also fallen prey to Agriotherium on occasion. This interspecies dynamic highlights the complexity of ancient ecosystems and the role of large predators in shaping the behaviour and evolution of other species. Chapter 3. Extinction and Climate Change. Despite its dominance, it ultimately faced extinction. The factors contributing to its disappearance are complex, involving a combination of climatic, environmental, and ecological changes. The extinction of Agriotherium not only marked the end of an era for Africa's bears, but also reflected broader shifts in the continent's ecosystems and climate. The Miocene and Pliocene epochs, during which Agriotherium africanum thrived, were periods of significant climatic change. The Miocene epoch, about 23 to 5 million years ago, saw the expansion of grasslands and the decline of forests, which had profound impacts on the habitats and food sources of many species. Agriotherium africanum, being a large omnivore, relied on a diverse range of food sources, including both plant matter and meat. The gradual shift from dense forests to more open grasslands likely affected the availability of these resources. As Africa's climate became increasingly arid during the Pliocene, about 5.3 to 2.6 million years ago, the environment underwent further changes. The expansion of savannas and the reduction of forested areas would have placed additional pressures on it. These climatic shifts not only altered the distribution and abundance of prey, but also affected the vegetation that Agriotherium relied on for sustenance. Another crucial factor in the extinction of Agriotherium africanum was competition with other large predators. The African continent has long been home to a diverse array of formidable carnivores, including large cats like saber-toothed cats, Machairodontinae, and early members of the lion and leopard lineages. These predators competed for similar resources, and changes in the ecosystem could have intensified this competition. Agriotherium, despite its size and strength, may have struggled to compete with these more specialized and agile hunters, particularly as prey species adapted to the changing environment. The interplay between climate change and competition is evident in the fossil record. As the climate became more arid, the habitats of many large herbivores shifted, leading to changes in their populations and behaviors. These shifts would have had cascading effects on the predators that relied on them. Agriotherium africanum, which may have been less specialized in its hunting and scavenging techniques, could have found it increasingly difficult to secure enough food. Furthermore, the extinction of Agriotherium africanum coincided with the emergence and evolution of early hominins. Australopithecus, an early human ancestor, lived in the same regions and time period as Agriotherium. While direct evidence of interactions between Agriotherium and early hominins is limited, it is plausible that the rise of these tool-using primates could have influenced the bear's extinction. Early hominins were becoming increasingly adept at hunting and scavenging, potentially competing with Ayat for food resources. The extinction of Agriotherium left a significant ecological void in Africa. As the largest terrestrial predator during its time, its absence would have reshaped the predator-prey dynamics in its ecosystem. The loss of such a dominant predator could have had cascading effects on other species, influencing their behavior, population sizes, and interactions. The extinction of it also marked the end of bears in sub-Saharan Africa. For nearly 3 million years, the continent remained devoid of these large carnivores. This absence is notable given the rich diversity of other large predators that continued to thrive in Africa, such as lions, leopards, and hyenas. The factors that allowed these predators to persist while it vanished are complex and multifaceted, involving a combination of ecological, climatic, and evolutionary forces. Chapter 4. The Atlas Bear, Africa's Second Chance. bears would eventually get another chance to inhabit Africa, albeit in a more limited capacity. The Atlas bear, a subspecies of the brown bear, Ursus arctos, established itself in the northern regions of the continent. Unlike the expansive range of Agriotherium, the Atlas bear was confined to the Atlas Mountains and surrounding areas in Morocco, Algeria, Tunisia, and Libya. This bear subspecies found a niche in the cooler, drier climates of the mountains, which provided a suitable habitat for its survival. The Atlas bear was one of the largest animals in the Atlas Mountains, with adults weighing up to 450 kilograms, 1,000 pounds. This size made it comparable to other brown bear populations and once again rendered bears the largest terrestrial predators in Africa, though on a much smaller scale than during the time of Agriotherium. The Atlas bear had a shorter body and long fur, which was reddish-orange on the underside, setting it apart from other brown bears. Dietary preferences also distinguished the Atlas bear from its relatives. It had a more vegetarian diet, with the bulk of its calories coming from roots, acorns and nuts, while small mammals and carrion supplemented its diet. This adaptation allowed the Atlas bear to thrive in its mountainous habitat where these food sources were abundant. Despite its success in the mountains, the Atlas bear never expanded southward into the rest of the continent. The Sahara Desert acted as a formidable barrier, preventing any migration attempts. The limited range of the Atlas bear meant that its population remained relatively small, and it coexisted with a variety of well-known animals, including the extinct North African elephant and Barbary lion. Chapter 5: Human Impact and Extinction. The Atlas bear's interactions with humans were initially limited, but this changed dramatically with the arrival of the Romans. In 146 AD, after establishing the province of Africa, the Romans began to export Atlas bears to Rome, where they were used in gladiatorial games. These brutal spectacles often pitted the bears against humans and other animals, leading to significant population declines. However, the Roman games did not completely wipe out the Atlas bear population. The introduction of modern firearms to the region had a more devastating impact. Guns made it easier and safer for humans to hunt the Atlas bear, leading to overhunting and rapid population declines. The situation was further exacerbated by the capture of bears for zoos and private collectors around the world. By 1870, the Atlas bear was declared extinct after the last known individual was killed by hunters in the Tetuan Mountains of northern Morocco. The extinction of the Atlas bear marked the end of bears in Africa for the foreseeable future. It was a tragic loss, as genetic studies have since revealed the unique nature of this bear subspecies. Two distinct clades of the Atlas bear existed, clade 4 and clade 5, based on mitochondrial DNA. Clade 5 bears were found to be genetically similar to Iberian brown bears, while clade 4 bears were highly distinct, sharing more DNA with Alaskan grizzly bears and polar bears. This genetic diversity raises intriguing questions about the Atlas bear's evolutionary history and its connections to other bear populations. Let their legacy inspire us to cherish and protect the remarkable species that still roam our world today. What other mysteries lie hidden in the annals of history waiting to be uncovered? Join the conversation and share your thoughts below. Together, let's safeguard the wonders of our natural world for generations to come.